Welcome to qnawire.
For this question, you have to use Newton's second law. For that, let me choose the following reference frame: a vertical axis that I'm calling y, and a horizontal axis that I'm calling x. Now, for the first item, we apply Newton's second law on the x-axis. In that axis, you get that the net force is given by the mass of the skater times his acceleration in the x direction. The net force that is acting on this axis is only the frictional force. So minus, because it's pointing to the negative side of the x-axis, the frictional force is equal to the mass of the skater times his acceleration. But the frictional force, we know in the kinetic situation, is given by the kinetic frictional coefficient times the normal force. So this is minus the kinetic frictional coefficient times the normal force, which is equals to m times his acceleration. But notice that on the vertical axis there are only two forces acting, the weight and the normal, and the skater isn't moving in the vertical axis, and it's not going to move. Therefore, the weight force and the normal force are equal forces. So the normal force in this situation is equal to the weight force. Then minus mu kinetic times the weight force is equal to the mass of the skater times his acceleration. The weight force is given by the mass of the skater times the acceleration of gravity. So minus kinetic frictional coefficient times m times g is equal to m times acceleration. We can simplify the masses to get an acceleration on the x-axis that is given by minus the kinetic frictional coefficient times the acceleration of gravity, which you should remember is 9.8 meters per second squared approximately. Then his acceleration is minus 0.1 times 9.8, which results in minus 0.98 meters per second squared. The minus sign indicates that the acceleration is pointing to the left, so it's decelerating with a magnitude of 0.98 meters per second squared. Then, on the second item, we have to calculate how far will he move before stopping completely. For that, we can use Torricelli's equation, which tells us that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the displacement. After stopping completely, his final velocity will be 0. His initial velocity is 7.6. Then we have his acceleration, which is negative. So minus 2.0.98 times the displacement. Now we solve this equation for the displacement. So 2 times 0.98 times the displacement is 7.6 squared, then the displacement is 7.6 squared divided by 2 times 0.98. And this results in approximately 29.5 meters. So this is the distance he will travel before stopping completely.